Jocelyn has been teaching the introductory course, but she's leaving. All right, so this is live now. I'm going to present to everyone. So there are two things. Can you all still hear me down on the coast?
Yes.
I need to probably project something, right? Oh, now you're seeing the back of Nicole's head. All right, there we go. And then share. There we go. So it doesn't look like y'all are seeing anything. You're seeing a Windows.
We're seeing our computer up here.
Okay. There must be like some input. I'm not sure that I can control the fact that you're seeing your computer. There must be some input. It's only 4, right? I'm with 411 now, but perhaps there's a. Yep, there we go. That was it for a second.
You gotta hold your mouth right.
That's it. All right. Is this 468 or 469?
468.
Okay, good. Got it right. Internet mapping is 469. Okay, so there's basically two things that I want to do today. First, this is the second week on raster. So the first, I want to review what we did last week since we didn't have a formal meeting and make a toolbox out of the tool that we made, or that I made on the video. And so I gave you a little bit of assignments to finish it off. And so we'll look at that and make it into a toolbox. And then for the second part of the course, or the second part of today's meeting, I want to discuss the way ArcGIS handles using or a fine-grained access to raster data. Now, we did this with vector data already. What I mean by that is accessing the individual pieces of raster data. So with vector data, that's what we're doing with cursors, right? We went through and we could go and touch every single element. If you think about GIS data, I said, what's the fundamental thing in what's the fundamental entity of a vector data set? Some people might say, what's a feature? But even inside of a feature, you can get attributes and then you get all the little points that make up the geography description, right? So, but with raster data, what's the fundamental piece of a raster? A single cell, yeah, pixel or a single cell. Those are both the right answers. So if we want to access individual cells, we can do that. And the way ArcGIS has us handle that is to convert them into an entity that that's called an array in computer science terms. Now, we've already used that term array. ESRI has this thing that it calls an array, but it's actually an object of its own design, okay? In computer science terms, an array is a large, well, it doesn't have to be large, but it is a portion of the computer's memory that stores a bunch of the same types of data together in a block of memory. So it could store a bunch of numbers, it could store a bunch of letters, but it stores a large chunk of, I said large again, it doesn't have to, but an array can have 2 elements, okay? But it could have 100 elements. But the point is, technically, an array can only have 1 element. And then it's just storing 1 entity or 1 number. So what it does, the way ArcGIS handles this is it just basically says, oh, you want to access the individual elements of this raster data set? Here is the underlying fundamental array. you can have it. So it gives it to you, and then you can do whatever you want with it. Python allows you to manipulate arrays by accessing the row and column number, by row and column number. So if you want to change the fifth row, second column, I did that the wrong way, second row, fifth column, the value in that data, you could a lot like a list, except for a list only has one dimension. You could kind of fudge it, right? With a list, you could have a list of lists, then you could have 2 dimensions, but I'll show you what I mean by that. So if I said A equals 2, 3, 4, right? And then I'll do this in the interpreter window. See, where's the actual interpreter? That's not it. Here. If I run this, we're on week 10. I'll just call this 2016 list example. All right, so that didn't really do anything. So I go back over here. I made A a list with the numbers 2, 3, and 4 in it. And I made B a list with the numbers 3, 4, and 5, 6 in it. Right? I could say print, or then I can make C a list of A and B. Put equal signs here. Print C. Run that guy. So I've just made a list that contains 2 lists, and I could call this, these rows and these columns. If I wanted to access the second row, third column, how would I do that? If I wanted to print only the second row, third column, I could do something like this. 1, 2. And what will that give me and why?
You mean item number 2, the original list, and the third item in the list.
So what's it going to print?
So 6.
Yep, it's going to print 6. So if I run this, it's going to print 6. Okay. All right. So an array is a little different. An array we'll just say something like this. If this was an array, this would be the proper notation. Okay, it's still 0-based, but we would say 1, 2 rather than. So a list is kind of like an array already, and you can make lists of lists, so you can make multidimensional arrays with lists. The thing is that lists are very high-level objects in Python, and there's actually a lot of overhead with reading and writing lists. Python does a lot of things for you, and they're not like arrays in that they don't take up a section of shared memory. And the reason that they can't do that is that do all your data types in a list have to be the same? No, that's absolutely right. So in a list, everything can be different data types, and so the computer is keeping track of every single element. It's just a bunch of variables that are being stored together, and it's keeping track of the data type and the number of each variable. That's different than an array. An array doesn't keep track of that because it doesn't have to, because every single element is the same data type. And so all it does is says, oh, okay, I'm taking this chunk of memory, however big it is. I said large before, should have said chunk. I'm taking this chunk of memory, it can be a small chunk or a large chunk, and I'm reserving the whole thing, and I'm going to store all these things in there, but they're all the same size, so I only have to store the size of the data type and then push the data into that portion of memory. And if I want to say add 1 to every single element or multiply every 1 by 5, it's really, really fast for it to do that. It can load it all into memory, add 5 to each one without even having to do a loop. Okay, the computer can do that processing. Modern computers can do that with a fairly large array if it's all loaded into memory. So it makes it really fast, a lot faster than working with a loop. I mean, working with a list. Okay. All right. I probably should have waited and introduced all of that when we actually started talking about numbers. So let's review the arrays, but let's review what we did last week. So I brought the script up from last week. Okay. This was the only assignment from last week, and I'm going to go ahead and save this script into week 10 because right now it's saved in week 9. So we're going to modify it a bit from week 9, but we're not really going to modify the data. So there's no reason to, if your data line still works, then you should be good. And if you missed last week and you didn't get a chance to work on this yet, you can do the same thing. This exists up on the Git page now on GitHub. So if you go into week 9 and you copy and paste this into a Python window, it should look just like this, and you should be right where we left off.
It's 9.1.
Yeah, it's 2016 Raber _9_1.py. All right. I'm going to say file, save as. I'm going to go up and save this in week 10 and call this, I'll call it 10. It'll be 10.1. The lab isn't quite typed up yet. When we get on our break, I'll finish typing up the lab. This will be 10.1, and so we'll hit save. So we're gonna create this. We're gonna turn it into a toolbox. Just a second. I don't know what this one was. Oh yeah, that was just the one I just made. It's like, I don't remember making that. I'm getting old. Yeah, I'm gonna close this up now. I don't know. I should have saved it. Okay. All right, so now that this is saved into M10, let's talk about let's review. Let's take a few minutes here and review what it's doing. We should all know what import argpy does, but we introduced this new concept last week. From argpy.sa, import star. Why do we need to do that? What is argpy.sa? Yeah, spatial analysis is what it stands for. All right, and just a refresher, that import star takes all the functions that are available in SA and imports them without the need to retype argpy.sa in front of them. So in other words, if we just said this, okay, what would we have to do differently? We would have to, down here, type in argpy.sa .Euclidean distance each time. So that's sorry, if this actually said import instead of like this. So those are two different syntax. Did you have a question on the code price?
No.
Okay. I thought I heard you say something. All right, so I'm gonna go ahead and undo all that. Okay. So this is the preferred syntax. It's in ArcGIS this way, but I'm just showing you that's like if you made your own model, like we did, we demonstrated with the circles, but we did that other week. You could do the same thing. You could import it and say import it. So this just means that import everything from this module. We don't have to append it. in front of everything anymore. Or another thing that we could do is say from arcpy env import star. Okay, so do that. Then we can get rid of the fronts of each of these. The only issue with that is that it's very possible that you might create a new you might create a variable called extent, or you might create a variable called workspace or cell size. Those sounds like things that to me might get used as keywords, and so I don't do that, but that is possible. Okay, next line, checkout extension. Spatial analysis is an extension, so you're checking it out. You're just telling ArcGIS license manager that you want to use it. All right. What's happening in this cell? I mean, this one right here, arcpy.env.workspace. That's something we did even back with vectors. What's happening there? What's the workspace? Right. So from this point on, if we're using a data set that's in that directory, we no longer have to specify which directory we're talking about. All right, so for example, down here, when we said for data set in data sets, we're looping, and it knows that we're getting those, oh, right here, sorry, list feature classes. This is the line where we're just saying, okay, everything that starts with risk star included in this list, but anything that starts with risk included in this list that we're later going to loop through. But we didn't have to type in d:/temp/m9. It knows that that's the directory we're searching through. Okay, now these are both raster specific, the extent and the cell size. And those are really important to set, because when you're processing with raster data, if you don't specify an extent, does anybody know what the default is?
Or just feed everything?
That would be nice. It's, well, depending on what, I guess you could say it's everything, but let's say I'm taking two raster data sets and combining them somehow. I'm putting them through a formula. I'm adding them together, or I'm subtracting them, or I multiplying one by the other. In that case, what's the default? It's actually the default is the minimum between the two. Okay, so in other words, it's the overlapping area, which in a lot of cases is very valid, because if you're multiplying two raster data sets, there's really no reason to include anything that's not in the overlapped area, because why? Anything multiplied by nothing is nothing. So, but there are some reasons, like with addition, that you'd actually want to include everything. Okay, and so anyway, that was my reason for pointing this out in the last lecture, is that it's often important to specify extent, because the default, if you don't specify the extent, will be the minimum bounding rectangle between the two rasters. Also, who knows when they're going to fix it and if they're going to fix it. So I may be wrong when I say this, but as of the last time I checked, Spatial Analyst still doesn't do projection on the fly when it's combining raster. So if you add two rasters that appear to overlap in ArcGIS, but they're in a different projection, you're going to keep getting errors forever until you figure out, oh, it's in a different projection. Even if they line up in ArcMap, for some reason, Spatial Analyst, when you go to run the tool, that's often an issue. So it helps to set the extent. All right. It also helps to set the cell size. Again, here the default will always be the maximum of the two inputs when you combine two raster cells. So it's always good to set the cell size. Okay, in our case, where we were actually creating new raster data, so we took all of our data sets and we calculated the distance, okay? It was really important to set the extent and cell size because we're creating new data. It doesn't know how big you want it, how far away do you want to stop calculating the distance? We need to tell it. So we just need to give it the whole study area. That's what we did with the extent. So extent can be a number, or extent can be a path to another data set. All right, this is what we do. We overwrite the output a lot. We've done that before. Okay, so we talked about what this does. All right. Okay. What does this line here do, right? Well, let's go line by line inside this loop. So this loop loops through everything that starts with risk. So if it's called risk roads, it's a roads data set. So what does this do right here? What does that line do?
Say how far the rings are.
Yeah, so, yeah, but like in simpler terms, in general terms, what does this tool do? The straight line distance to something.
Right.
But what, is it creating a new data set?
Yeah, it's a data set. No, it's referring to data set.
Yeah, you're right, that is referring, that's the input.
Right.
This is another number. This is the name of what?
The function we're
The
doing.
function.
Right.
This is what?
That is your variable, whatever you labeled.
Right. What's another way to say that this right here? The out Euclidean distance. That's the name of a variable. Okay. But if we think of this as a function, what's this receiving? Yeah, the output. It's a good way. That's one way to say it, or the result of the function. What's in the result of that function? Is it a what is it? What data type is it? Yeah, it is kind of like a buffer, but in general terms, you know, like if I just said x equals 1 plus 2, what data type is x? What's the value of x, first of all? 3, yep. So what data type is x in Python, probably? Integer, yep. Okay, so I just said out Euclidean distance equals Euclidean distance, which is the name of a function, data set, comma 1000. So what is out Euclidean distance? It's more complex than just a number, but it's still can be boiled down into at least a word or two. What are we learning about? What did we learn about this week? What was the purpose of this lecture? Raster data, right? So what is out Euclidean distance? Yeah, it's a raster data set, okay? So this function took as an input a vector data set, right there, and it took another parameter that actually has a few other optional parameters, but I didn't give the optional parameters. Took some optional parameters, and the output is a new raster data set, okay? Now from last week, if you watch the video, you'll know the answer, or maybe you'll just know the answer. But at this point, where is that raster layer saved?
Not yet.
Right, but it does exist.
Yeah.
Where does it exist? That's a great guess, but it doesn't exist even in the workspace yet. Yes, it's only in the computer's memory. And if it's too large, the computer kind of, it does something that lots, like Photoshop does the same thing when you have a very large file in it. It creates some memory on disk, which takes longer to read and write, but it's still memory. If you close up ArcGIS, you'd actually delete those. The operating system itself is actually taking care of this pretend memory that's existing. But in any case, it's not permanent memory. It could exist on disk, is what I'm trying to get at. But even if it exists on disks, it's in the swap memory, not places that you could actually find it. Okay, so it's in memory at this point. Especially these data sets, they're not big. They're definitely only in memory. They're not, unless we're working on a 10-year-old computer. They're not anywhere on disk. Okay. All right. Next, risk data set equals 1,000 minus out Euclidean distance. Okay, what's this doing? Right, it's flipping it. Same thing though. This risk data set is the output. And then this is kind of like our example where we said 1 plus 2. We're saying 1,000 minus a raster. What happens when we do that in ArcGIS? 1,000 minus a raster. What's actually happening? Like,
Gives a new raster set.
right, where, what have we done with 1,000? What's that? Exactly, where each value is subtracted from 1,000. Okay, so it's kind of cool. That's a raster. That's the way rasters work, even inside of ArcGIS. So 1,000 minus Euclidean distance takes 1,000 minus every value in the raster and saves it over here. And we did that, like Caleb said, to flip it. So here we have values that ran from 0 right next to the road feature, all the way out to 1,000 meters in this case, away from the road feature. And now we've got them going the opposite direction. 1,000 right by the road, 0 as you get all the way out. All right, that's what that line does. This FRIS data set, which in my mind, I think the reason why I did that was because it's final risk data set. Should have come up with a better name for it. What does this con do? What is the conditional? Oh, I already said it. It's a conditional operator. Okay. All right. So it's a conditional operator, and the way a conditional operator works is the very first part here is the condition. So this is the condition that's going to evaluate. We could put, and this is what we did in the video last week. We could say something like, if the value is greater than 40, we're going to get zeros and ones in our output data set where it's 1 if it's greater than 40, it's 0 if it's not greater than 40. So here we put another function inside. This function is also going to return zeros and ones. This function is called isNull. So what is this function going to do? If it's null, it's going to return a value of 1 actually. But that's exactly opposite, so it's almost exactly right. So it's going to return a value of 1, and if it's not null, it'll return a value of 0. So it's a 1s and 0. Is it null? In other words, is it no data? If it is no data, then, okay, sorry, a little bit further ahead. It's going to be 1 or 0, okay? So con then will accept a 1s and 0s grid and say, okay, well, if it is 1, then do this. If it's 0, do this. So that's what that's doing. So in effect, what we're saying is, if the current risk data set has a null or no data value, assign it a 0. If not, carry through the existing risk data set value. So all it's doing in simple terms is what? What's a more simple way to say that? What's it doing with the no data values? It's getting rid of them and turning them into, exactly. So the simple way to say that is, that statement takes all the no data values and turns them into zeros. All right? Why am I doing that? Because what is no data plus no data in any raster or GIS out there? Or no data plus, sorry, what's no data plus a valid number in any raster data set out there? Raster GIS. Right.
Doesn't have anything to reference.
Yep. So no data plus 10 is no data. No data plus 5 is no data. No data plus 100 is no data. What is 0 plus 10? Still 10. And that's actually the behavior we want. Okay. Because what we're trying to do is look at the additive risk factors. Okay. That's our scenario. So we're combining a bunch of risk factors up, and we're coming up with an overall risk value. And that overall risk value needs to be additive. And so if there's no risk, it needs to be 0, not no data. That's why we changed that. That's probably the quickest programmatic way to do that. All right. Okay. So then this is where we do save the data set. We save it out right here. We replace, what we do is we take the current data set and we just, this is a function that we do on what data type? What is the data type for a data set right now? Where do we define data set? We define data set right here. We define data sets right there.
This, right?
So data sets is a list, but what's it a list of? It's one of the fundamental data types. It's not a special object that ArcGIS created. It's just not a number, but it's a string. Okay, it's a list of strings. So this outputs a list of paths, but those paths are just strings. And so replace is a string function, and we're taking the string function .shp, or sorry, we're taking the end, the .shp portion, and we're renaming it _risk.img. So effectively, what are we doing there?
From a shape file.
We're going to do that. We're basically taking the name from the shapefile and preparing it to be the name for an image, and then actually saving it. So yeah, maybe you were saying what this whole line is doing, right? And I was saying what this started. Oh. You're right though. This is saving. It's not actually converting this shapefile, but it's taking the name of the shapefile and turning, like let's say the name was called bob.shape. Then what this would be doing is turning bob.shape into bob_risk.img, because it's replacing .shape with _risk.img. So what I'm saying, if it was called bob.shp and I've replaced, let's do the replace. Control C, I'm copying and I'm pasting the new thing. So anywhere that it sees .shp in the string, it's going to change it to risk_img, and I'm going to get bob_risk.img. That's what that line is. All right. Let's run it up to that point and see what it does. I'm gonna comment out this eval statement right here, and just write. I'm just gonna comment that out. I'll run this guy. The last day on the I didn't wear sunscreen just on my neck. Everywhere else I wore it. Now this collar shirt's bothering me because I have a t-shirt on. All right. It was hot and sunny. I'm getting in air. All right, let's debug. Okay, it looks like in my version, I don't have the data in that path. So I have to put the data in that path. So if I go under Ty Dixon Park data, I'm going to copy this. I'm actually going to put it on C temp, put it in C temp, and say paste. Oh, it's already there. Okay. There we go. So I'm going to go C temp instead of the current directory I have it saved in. And I'm going to save this in the same place. Oh, sorry. I have to still give it the name of the watersheds part. So it's actually like this. Okay. And then this one would be, I'm going to save the outputs to this directory as well. Ctemp, Ty Dixon part data dot. You can put the outputs wherever you want. So this is where I'm putting my outputs. Ctemp, Ty Dixon part data. This is an area in Jamaica. Outputs. This is Ctemp, Ty Dixon part data, Ty Dixon watershed matching. So make sure that that's a valid path, and then your script should work. This also needs to be a valid path that exists.
Can that pop up for a minute after it?
I'm sorry?
Can that pop up for just a minute?
Yeah.
So I don't want to have to.
Yeah. Second. Sorry. Yeah. This needs to be this. When we turn it into a toolbox, we'll let it save somewhere else. But for now, the workspace is where it's reading from. It's also where it's plopping the data out. So that's what it needs to be, depending on where you put the data. I put it in Ctemp. I'm going to save this. There you go. Try to make this smaller. Okay. If you need me to move that over, let me know. So each time through, I caused it to print the name of the data set plus some other name that I was using as temporary. I didn't actually end up saving that out. So it ran through. And if you look at, I gotta open up our catalog. Yeah.
But that's a good way for me to keep my data all in one location.
Right.
I'm solid state.
So C temp. Type extend. Oh, not an output. So I should have done this. I should have showed this before I even ran it. But see how for each risk data set now. So this is the risk data set. If I look at the geography, so those are small scale agriculture activities, and this is the risk layer. In other words, it's just finding the Euclidean distance. In reality, the way that this was actually implemented is that each of these risks got a different weight. And so we could multiply each one of these by their weight before we add them all up, but I just had you add them all up. Yeah. So here's a sugar cane, here's mines, quarries, and here's roads. Okay, but out here, the values are always 0, and then they get bigger as you go out. And in fact, they didn't all have values of 1,000 either. In the original scenario, they all had different distances associated with them. All right, so here, I'll leave that up again for a second.
Can you show the other window, the running window, just to make that up? I got a bunch of stuff, I'll make sure it's the right stuff. Okay, my brand cursed did not, so.
What kind of error did Kristen get? Did you get, Kristen?
It's my file. I'm just gonna pick a different place to put it and get that.
Yeah, sometimes rasters are actually even more finicky than vectors in terms of the spaces and the permissions.
It's by ransom, so.
Yeah, well, it's based on much older code. Raster GIS is actually older than.
Oh, yeah, because the old pixels of field 8-bit stuff.
Right. Yeah, pixels were around.
Oh, yeah.
Or.
I remember my Atari, I know. Commodore 64.
All right. So while you're checking that, I'll just move this over. You can hopefully still see it. Oops. Function. There we go. It's almost like that needs to be a little bigger. This needs to be a little smaller. Maybe like that. So, so there's not any really good way. What we want to do is add up all of the data, right? We want to add all of it. We want to add it all up. Okay, every single one. And there's actually not any really good way to do that. It's kind of like a problem because in Raster Calculator, you need to give it the name of every single input. You can't say input, create a list and then you got it. Okay. And so, this is getting off the board just a bit. And so that's why I'm doing this. It's kind of like a workaround. It's improvised. I think that's the word. We have this one contraption. So we're trying to collect depth when we go down there to the islands. We have this contraption just as like wire. It looks really ugly. It's got PVC on it, but it works so we can get it all on an airplane. We can unload it and we can stick it on the side of somebody's boat. Somebody was looking, and it looks really ugly. Somebody was like, "Is that improvised?" I'm like, "That's a nice quiet way to say that it's like jerry-rigged, basically."
Engineer.
Yeah.
Like,
So yeah, this isn't the cleanest code. In fact, a lot of people will tell you that having an eval statement in your code is not good. You shouldn't do it. But I really didn't see a way to get around it because what we need to do is feed. We need to feed ArcGIS a string with the names of all of our rasters. But we don't know the names of all of our rasters until after they get created and in the loop. And so what you have to do is do a statement like this, and that's what this statement is doing. It's basically turning each of these data sets. We did cover this, but it was pretty briefly when we covered it. You can basically take a list and feed it into this string function, and it will join the data. Let's do a better example of that. Okay, so, or sorry, let's do that right in the Python interpreter, this right here. Okay, so if I have a list that says A equals George, oh, there should be a list. All right, George, April, and Lloyd, a list of George, April, and Lloyd. I could say, hello, dot join, hey. Might be better to say, that didn't really work. But, well, we did. No, it'll go in between. Is the see how the see how it went in between? It joined this list and put hello in between. Okay. It doesn't go up. So if I want to say hello to everybody, then I actually could do something like this, where I say hello plus that. Then it will say, I gotta get the syntax right here. So now I have hello George, hello April, hello Lloyd. It's a silly example, but this is what I was doing up here. So I need raster around the very first one. So that's why it says raster parenthesis plus. And then I also need the word raster around every single other one. So when I print this final statement, I'm going to print this. Run the guy. The problem really is that we get a bunch of strings here, and we need raster data sets. And so we have to take our strings and convert them back into raster data sets. Where's my it didn't actually print the statement, did it? Did I run this? Yeah, I did. It's dying right there. Is anybody else doing that? Am I getting some error? Python stopped working. That's scary.
Like you said, raster data is authentic.
Well, I'm not actually trying to do anything. I'm just creating a string. Yeah. And so this. All right, so what I'm going to do here is print the risk rasters. Print risk rasters. This should just be a list. Well, it's failing on. Actually, was it always doing that thing that it did at the end? So is it only failing on the print statement?
You have it open somewhere else? You have it open in our catalog.
That's a good point.
I'm trying to roll out.
I wonder if it's just having an issue replacing that data because it was still open in our catalog.
Wait, what was it? I think mine printed.
Probably will be.
Yeah, cool. So I'm gonna replace this, bring this back. So yours printed, that's good. What did it print?
R, risk road, risk energy plus raster, risk town, risk image, plus raster, something. They printed out the whole statement.
Okay. Yep, great. So I think mine will print this time too. There it goes. Yep. So now we have this. Now we have this statement. This is actually a Python statement. So we've prepared a line of Python code to run. That's what this line did. But then to actually execute that line of Python code, that's when we run this line of code that says eval. So eval statement will actually take this new line of Python code and run it. So I think I did demonstrate this last week, but like we could say, you know, what if we said, quote, A equals 3 plus 4, okay, quote. And we save this as a variable called, you know, thing equals A equals A plus 4 in quotes. Okay. Now, if I say eval thing, what's going to happen? I guess you can't do assignment, right? Okay. Let's try a different example. Quote, print, or sorry, A equals, quote, print, George. Okay. And then I say eval A. What's going to happen now? Yeah. Still not working. Anyway, I don't know why that's not working. I'm trying to do an example. But eval is going to run this set of code. Okay. All right, let's try running it. I think that it just can't accept an entire statement. Yeah. Okay. So this is what I asked you to do. Set this equal to some variable. Let's call this, you know, final risk. Or overall total risk. Total risk equals eval statement. And then we need to save it to some location. So we need to do something like this. Let's just save it as total risk. Save that to some location. Oh, there we go. Okay, so the reason why these statements weren't working up here is because I'm taking a whole line where I can only take a portion. I can't assign a value out. So here, this is just the left portion of the equation, and I'm still assigning it to the total risk. I can't create a variable inside of this statement. All right, so my total risk should be in there now. And there it is. So that's the additive of all the risk factors right there. Just add them all up. Okay, and so, yeah, go ahead.
You got a minute, you can't get Kristen's to run. It's working on mine, fine, I can't figure out what's wrong with hers.
Okay, yeah, so I think the best thing to do would be just for Kristen to just send it to me and I'll look and evaluate it here and then I can send it back to you.
Okay.
Yeah, send it to george.raver@usm.edu or graver@gmail.com. Okay. So this is the position where we're going to turn it into a toolbox, and then we're going to do two different activities today when we start learning about NumPy. One of them is that one of the advantages to NumPy is that we'll be creating a we can turn each one of these into arrays, into variables, and we can have NumPy add them all together. And NumPy will add them all together just inside of NumPy. We can add 10 arrays together, or 20 arrays together, or whatever. And so we don't need to do this function here. And you'll see that it's actually a lot faster.
I'll send it to you.
Okay, awesome. Okay, so I'm going to start by changing just the paths, and then we'll be able to isolate and see if that's the problem. Oops. So were you getting any messages, or was it just red?
Yeah, it's I'll change the paths like several times I had on the desktop and do those paths and
I still.
You download the actual data and see versus error.
Now, is it unzipped?
You saw the pop-up window too.
That's because I still had it open.
Oh.
I'm pretty sure, because that was the same error. But we'll see in a second if I'm right. Nope. Now that is still freaking out. Oh, that's because I think it's because we're doing this. There does seem to be some other error happening, Kristen. Let me try to figure this out. But yours was not even showing these blue names, right?
right, I think that's a problem.
Okay.
Fix this and we'll show you.
That's really kind of odd. Okay. Whoops. What's that?
Oh. number of tabs you have open.
Yeah, I have a lot.
Yeah.
All right, so you think you got it so that it prints the names like this? Still an error. What does the error actually say?
Trace back file. In line 8, it says my file.
Does it say something in there about does not exist or is not supported?
Error in assessing environment.
Error in assessing environment. Can you copy and paste the error code? I mean the whole red text. And send that to me.
There you go.
All right, got it. Yeah. Okay, so this is the line of code that it's having a problem with. Okay. So at GHY 468, week 10, you verify that it is there, right? Like if you highlighted this line, the stuff that I've highlighted, and you went into here into Windows Explorer and pasted, pressed enter, I get this. If you get a similar error, then it's not really there. If it attempts to open it or navigates to that portion, then it is there.
Dixon, it's just spelled.
Oh yeah. Ty Dixon.
That's it. Dixon Park.
We got it.
DIXOTN. Yeah, that's what the problem is.
Okay.
Yeah, we got it.
All right.
Like it's running now.
Okay, great. Awesome. Okay. So so here's my original my original data set back up, and we're gonna yeah we'll convert this into a toolbox here real quick. Okay. There's a few things when we convert it into a toolbox. You don't want to have this line of code in there. Okay? Why not? arcfind.env.workspace.
Because you're no longer saving it files specifically in that folder. You're instead creating the toolbox and using your toolbox.
Right. Maybe another way to say that, I think that what you're trying to say is that the toolbox should be general. It shouldn't care if the data is in a specific location. Because if it does care if there's a specific location, there's really no point in it being a toolbox. The toolboxes are great so that you can specify where it is that you want to save it. So one thing though is this is meant to run on what? A bunch of data sets, okay? And so perhaps we could leave this line in there and let them choose a folder instead of choosing a bunch of data sets. Okay? So let's think about that. What should the input, like when we open up our tool, what should the inputs be? It might actually be best to choose a folder or a file geodatabase. Would be good. We definitely want to let them choose the extent and the cell size anyway. So maybe we should just make all of these our inputs. And then I would argue that this would also be a good input. In other words, do you want them to allow them to put the feature classes and have a filter there? So do you want to just include all the feature classes? How do we say all the feature classes, by the way, instead of just one to start with risk?
Just leave it blank, wouldn't you?
You could have made a blank, exactly. That would actually work. But also, if you just had a star, it would do the same thing. So do that. All right. Now we may want to specify where to save it, or our tool could just always save it into the same directory, just like this current tool works. Maybe we'll just do that. We could ask them how they want us to, what they want us to call the actual final output result. Okay. All right, so let's do that. So these will be the inputs. 1, 2, 3. Those will be the inputs, and so we'll leave that in there. The output will be this, the total risk.img. Oh, 4 inputs. 1, 2, 3, 4 inputs, 1 output, and we'll be all set. So let's go into our catalog for week 10. See, this is my week 10 folder. You can have yours wherever you want. Under week 10, oh, sorry, I'm not in our catalog. I gotta be in our catalog because I can't create a new toolbox without our catalog. All right, so here's our catalog. See, courses, week 10. All right, so I'm week 10. There's nothing in there yet that it can read because there's no unzipped data or anything. But here I'm going to say new toolbox. Is it going too slow? I'm going to call this tool, let's call it add or risk calc, risk calc.toolbox. Then inside risk calc, I need to add a new script. Yeah. So I created a toolbox. Toolbox name isn't a big deal. I can call it risk calc. Now I'm going to make this script. I'm going to call the script risk calc 1. Okay. Risk calc 1. And I'm going to remember to check store relative path names. What's that going to do?
Save everything to that same folder.
Right. So as long as I save it to the same folder as my script, I can move both of them anywhere I want, and it'll work great. So store relative path names, and now I hit next. Now I got to find out where my script file is. My script file is already in this same directory, so I can just choose it. So I hit this, and I go to the same directory, which in my case is C, courses, SPA, M10, and then here's my script, 2016 Raver 10.1. That's fine, run Python script in process. All right, so this is our old friend, the script tool. Let me know if I'm going too fast. So this is our old friend, the add script window. So we said that we needed 4 inputs and an output. Okay, so let's go ahead and add them all. One's going, instead of calling it a workspace, let's call it data location, just to be more friendly. So that's the input data location. Okay, and our input data location, we can actually tell it that we want them to have to choose a workspace. So it will allow them to pick a folder or a geodatabase. That's what workspace means. So that's good, right? All right.
What did you choose for the last file on the, if you like hit back and you choose that file that you're looking for, the script?
Oh, the script is the one that we've been working on, like the one that you sent me that you were trying to find. So wherever you save that on disk. So I'll hit back. So this is the script. Like this is this script.
Okay, because I clicked that and I added it and then went next and it didn't there. Now it's all those fields are filled, but for some reason whenever I first did it, that box on the bottom, like on the next page, the box on the bottom didn't have any diagrams for some reason. I don't know why.
Oh, okay. Maybe it's just a glitch. All right, so the next one was the extent. So let's write extent data set. So we want them to provide a extent. In fact, it may be more appropriate or prettier to say, not prettier, but something that would be understood outside of our GIS world. If you have the study area data set, the study area is defined by this data set. Okay. And this one, we can specify that we want them to provide a feature class. Or actually, let's say a feature layer. I don't know if you remember the difference between those two. Anybody remember? Difference between a feature class and a feature layer?
The way they're saved, isn't it?
For these purposes,
Yeah.
it's, I mean, it could be the way that they're saved. Okay, so for what we're doing here, if you say feature layer, if you're running the tool in ArcMap, it will give you a drop-down button and it will allow you to choose from any feature layer that's currently loaded in ArcMap. It'll also still give you the little file navigator to allow you to navigate to a feature class, okay? If you say feature class, it will only let you navigate to a file location. It won't give you the drop-down. So the advantage of doing feature layer is it allows the user to select something that's currently loaded up inside of ArcMap, okay? That's really the only reason to do it. If it's a tool that will normally run in our catalog, which we're going to run this in our catalog, but even if you're going to run it sometimes in ArcMap, use feature layer. So that's why I like to use feature layer because of that. All right, the next one was cell size. Cell size is going to be a string. It's just It's just, that's what it is. And then I think the last one, oh, we wanted to say filter. File name or data set, let's call it. Data set name filter. Okay. So we could also make that a string. What that'll do is allow the user to actually type risk. One thing that we could do is change the type to be required. We could change that to optional. We could change that type to be optional. In other words, they didn't have to put a filter. The thing about that is that if you write optional, your code still has to handle that they didn't put anything. So keep that in mind. So our code's still going to have to handle that they didn't put anything there. It's going to pass an empty string if they didn't put anything at all. But that is helpful. All right. Okay. Then what was the last one that we wanted to? Yep, output name. Output name, and then oops. This can be a see if raster data set is on there. It has to be a raster.
Yeah, it's on there.
Yep. Yeah. We don't want it to be a raster layer because it's not created yet, so it can't be a raster layer. Tools will rarely create layers. Like they can, but it's usually if it's copying an existing layer and saving it to disk as a layer file. All right, so you get output name and all that, all that stuff. Okay, so this should work. One thing that might be helpful is, that's good. Okay, I think that's good. That's good. We got the order pretty close to right. Oh, for output name, we do need to change the direction to output. Now, I don't know if you remember when we discussed this, probably in 3 weeks now. Why do we have to do that? What's the difference between, because they're both, the user's providing both of them, so they're kind of like inputs. If we're talking like a function.
But we got to save that to a new file.
But we're handling that in the code.
Right.
So what does this toggle actually do that's different? It doesn't actually write anything. It still passes it to our code. What's that? Yeah, that's exactly what I'm getting at. If you select input, it's going to be prompting the user to select something that already exists. And if it doesn't exist, it's going to say that doesn't exist. Output is going to be prompting the user to create something new. And if you select something that already exists, it's going to say that already exists. And depending on whether or not they have override outputs turned on or off, it will allow them to use it or not. That's the difference. Is that this is more about the user experience than it is about actually having it be an input or an output. Okay. All right, so that's something that we have to do. So workspace, feature layer, string, raster data set. But the thing I was going to do, I'm actually going to do it, just so we don't have to enter it every time. For cell size, and plus it's important to kind of remember it, let's give it a default value so the user doesn't have to type it every time. Our default value, we'll make it the same that actually exists in our data set. That's where it's, it's 50. So make it 50. Yeah. I'm sorry, you also had a default?
Yeah. The data type for cell string or cell size can be cell size and a string.
Because that's one of the data types.
Yeah.
Say in.
Oh, yeah, you're saying, why not, yeah, cell size. Yeah, that's a good point. So, yes, and it's still going to pass it as a string, but using a cell size is about user experience. So now they'll only be able to enter certain things that are valid things to put in there. And you saw that the default value is max of. That's the, sorry. That's the default value, and I did tell you, like at the beginning of class, remember when we were talking about the default values? That is the maximum. The maximum of all the inputs is the default cell size. So I can change that to 50. Okay, but I do like that. That's more finesse than saying string there.
Still default 50 though?
Yeah, I'm still going to go with the default 50 just because that way we don't have to change it. Because a max of will actually, I don't know what max of will do in our case. Because what's the maximum cell size of a raster that doesn't exist yet? Right, so for our case, we need to explicitly define the cell size in order to have any confidence in what the actual value produced will be. Because if we don't explicitly define the cell size, we don't know what our GIS is going to do. It's going to do something, and it may be acceptable, or it may be unacceptable, or the third option is it could cause an error. So it's always helpful to do something that you know is a proper value. All right, so finish that up. All right, so now if we edit this guy, it takes us to our script. I don't want to do that. Sorry. If we double click on this guy, yeah, double click on it. Why isn't it opening? It's opening, but it's opening behind it for some reason. I'll minimize it. Where's it putting it? That's really strange. It's not showing it. Is it behind something? I can see it open right here. All right, I'm going to close down our catalog and reopen it. Because we got to be able to run the tool. No, I still need to update my script. Problem is I can't see. Do you guys, when you click on Risk Calc 1, are you getting the big version of this right here? See this little window? Yeah. You're getting that. Yeah. For some reason, mine's not popping up. I click on it and I get this.
You shrink down that to see what's hiding behind.
I did. I moved it around.
Yeah, I was going to
Maybe it's also because it's being recorded or something. Anyway, if you open this, you'll see that now we have, what does it say for cell size?
50 specified below.
Okay, 50, okay. So that's what we wanted it to say. We still have to modify the script to make this work. Okay, so everything looks good. Well, what we have to do is change this script to to work with the
to
connect to toolbox, exactly. So what is the way that we do that? So we're going to comment out each of these lines of code. Okay, even this line of code right here. Well, let's not comment that out yet. Actually, we'll do something like this. We'll say a filter equals, oops, looks like filter turned blue. So we'll say file filter equals, and then we have to type something there. Okay, so these are 0, 1, 2, 3. Let's look back at GitHub for a second. And look back at week, what was the week that we built the toolbox? 8. No, I think it was 7. Working with GIS data. Nope. It's been a little while. We did it at 6, I guess. Building toolboxes. Ow. Okay. Yep. All right. So you all remember the syntax here? ArcPy.get parameters as text, ArcPy.get parameters as text. That's what we need to do there. Because what's ArcPy.get parameters as text 0 evaluate to on our new toolbox?
First thing in our new toolbox.
It's the first thing in our new toolbox, which is what? Workspace, exactly. Okay, and then 1 represents, I actually did them in the same order, so it wouldn't be hard. So you can either type or copy if you want. We'll go in here, this is 0, this is 1, this is 2, 0, 1, 2, and then for this, I'm going to say plus star. So now, whatever, I can delete this part. So whatever they entered, even if it was nothing, even if it was, if they left it blank, because they can leave it blank, the optional. So even if this is empty, it's always going to be plus star, and so it'll return everything if they said optional. If they just said okay. If they wrote risk, then it'll turn this into risk star. And then what do we need to do in order to feed that into this line here? Yep. Do we get rid of the quotes?
Yes, because it's already present.
Yeah, because that's a string, right? So you can't really look on.
It's a string, and we need to not give it a string. We need to give it a variable that is a string. Yep. So good. So that's right. File filter. So now this should work, except we also want to save it, right? So we could just take this one more time, put it all the way down to the bottom. What's 0, 1, 2, 3, 4? Okay. Now, I always think this is kind of hokey because all the time people say, "Oh, that's great. That's a great tool. Can we add another parameter? Can you just throw in the ability to do this or that?" Okay. So then I have to go up here. You always want your outputs to be the last one. That seems like. So we have to go up here and we have to renumber everything, 0, 1, 2, 3, and then we have our new one, 4. But with this at the bottom, you always forget about it. I like to have all mine at the top, okay? In fact, if I were to do this, I'd actually take this out and put it above here. And then I would say something like this, output location equals, and then make that 4. Okay, and then I would go down to the bottom and change this to just output location. Okay. It does the same thing. I'm just telling you, oh, go ahead, sorry. What's that?
But you're just defining it with everything else, so you just make it have like a variable and it saves it.
Right. Yep, that way, all my variables that the user can change inside the toolbox are at the top of the page. And if I need to make a change to one, I need to add one, then I know every thing below it, I need to increment all those numbers. It's all about, it's organization, not requirement. So I just did that, okay? And now I'm going to test it. I don't know how because it's not working for me. Let's see if I open up ArcMap, if it'll work in ArcMap for me. All right, so here's ArcMap. Where'd I put it? See, oh wait, I need to add it to the toolbox. There it is. Okay, for some reason in ArcMap it's letting me choose. Okay, so now I say the input data location. I'm going to keep that the same, C temp, highest and park data. The study area data set, I'm going to choose the watersheds. Okay, I'm going to leave that the same. Data set name filter, I better type in risk because otherwise it's going to do it with all the data input sets. So it'll be weird. And then output name, this time I'll test it to see if it works to save this and just see data. Yep, and I'll call it test.img. Save it right there. Okay. All right, now here's the moment of truth. Is it going to work? No. Input data set does not exist or does not support it.
I got a syntax error.
You got a syntax error?
Yeah.
Is
this what you got?
No, I'm just reading here.
What did your error say, Bryce?
Syntax error, invalid syntax. It's got my file name for the code. It's line 7 failed to execute risk calc 1.
All right, read that one more time.
It says syntax error, invalid syntax. It's got my file name for the Python script.
Yeah.
It's line 7 failed to execute risk calc 1.
Line 7. Okay. Yeah, the failed to execute risk calc 1 is meaning that your data didn't run. So my guess is on line 7, if you go from the top, 1, 2, 3, 4, 5, 6, 7, you've just got some syntax that's not right that you need to clear up. If you want to forward it to me, I can try to test it out. One thing that I'm going to do is I'm going to say arcpy dot add, what is it, message or messages? Because I want to see what this is saying. It's even getting to that point. Oops, that's not going to work. That's not going to run. Oh, you know what? Okay, when I press OK, how quickly did this come up? Almost instantly, right?
Like the last time was 2 minutes of seconds.
Right. Okay, so if I look at my code, here, it is not even getting into this mess yet. Right? It's not even getting into that because this takes time to do this. So it's just going directly from here to there. Okay, it's going from here to there really fast. What could be the problem? Why would it skip this loop? Yeah, it's having trouble finding the data. So, oh, I totally messed this up. Output lock equals file filter equals.
We have 2 equals in the same line.
Yeah. I don't know what that's doing. Okay. So I think I copied and pasted and got careless. So
if you don't have that output, like you had before, where you didn't find the output and then at the bottom, save it to that output, that will look. Like mine's still not running, it's saying file folder is not defined.
let's see what mine says. Let's see if mine runs through. So when it's doing those little blue things, it's actually running something. And if I was going to do this better, I had all those print statements. I would change those into add messages. So anyway, mine ran through, and look how long it took this time, 22 seconds. And let's it actually because I'm running an ArcMap, it plopped it into ArcMap.
Can you go back to your code over?
Yeah, just a second. Okay. So my only real issue was that I wrote input lock equals file filter equals. And so what it was doing is you can't actually, it was valid syntax. If I say 4 equals A equals B, what I'm doing is assigning the value 4 to A, and then I'm assigning the value in A to B. So what it was doing was changing file filter to whatever 4 was, which was, I called it test.img. So it was assigning test.img there. So what effect was that having on the list feature classes? So the file filter was being given test.img. So I was saying test.img star. How many feature classes have test.img star in them? Or test.img in them? None. Exactly. And so because I was giving it a filter with nothing in it, that resulted in nothing, it ran, but it was a, remember we talked about errors before? It was basically, it was a logical error. The computer didn't it created a runtime error down here, but not until that point, because there was a logical error earlier in the code.
Well, Dr. River, I sent you mine, but I did some editing and it appears to be working now, so I don't think that's
Okay.
a problem. Wait, failed to execute. Never mind.
You did get failed to execute?
Yeah.
Let me look here. You may or may not have to send me your, okay, So this is the script that you're trying to run from.
I got a different error than when I ran that one. I've got saying line 25, blah, 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 one-time error, Python.
The one thing I've noticed is that you didn't update any of these workspace extend or cell size. Did you update those yet? So,
No, I don't think I
so see these 3 lines right here that I'm pointing at?
Mhm.
Okay, in my code, they look like, what did I put?
I mean the archive get parameter.
Yeah.
Yes, I did change all those.
Okay.
I changed those a while ago. I guess I don't think I clicked save before I uploaded that because I changed that a long time ago.
Okay, well, just because you changed it, if you try to run it again in ArcGIS, it doesn't see the changes until you save it as well. So you need to save them before you run it in ArcGIS, or it doesn't see them.
I'm just saying, where it's just saying, non-type object is not iterable.
That seems like it's also,
It says line credit 2, and that's when I run the if or for statement beginning.
right. So it seems like it's another problem generating the data sets. So there's some other error that's causing your data sets to not be a list of files. Okay, if you want to send it to me, you can. I can look at it. Because there's no more paths left. So now I don't have to change the paths. I can just throw it in my toolbox and we can check it out.
I'm still working on the script. We've got the input data, the study area data set, and all that. So I missed that.
All right, I'll just open this back up for you. Okay, so edit, so properties. This is what you want to see.
That. We click on it to click the little, put like the specific thing, the specific
Okay.
file names.
So we only did anything fancy with cell size,
Right.
and output name. I don't think we did anything else.
Right, I got that. Now I'm trying to actually unite the script with,
Oh, so you need to see the script.
well, I've got the script typed up.
Right.
I just need to find where to put it.
This stuff?
I've got that.
Oh, okay.
I'm now in Art Catalog. Like, all right, Art Catalog.
Okay.
I clicked on Risk Catalog. That's where I am.
Okay. Well, you just need to fill out the form and press OK.
Right, that's what I didn't do, because I didn't know exactly, I got here, it says that.
So your input data location is the workspace where you've been saving all your data.
Okay.
For me, it's Tidy Exton Park data. And then your study area is just manually choose the watershed, this one.
Okay, there it is. All right, that's what.
And then data set filter name, type in risk, and then, yeah. Good. All right, so I'm gonna look at, so which one of these, 1 minute ago, okay.
Oh,
Oops. Showing folder. Zero, 1, 2, 3, 4. Okay, so what I'm going to do, Kristen, is I'm going to go into properties and change the source to your file, see, actually that's just under desktop, drawer driver, downloads. Open, okay. I'll try to run this guy, see what the error is. So this will be Tide Ixton Park data. This will be watersheds. You can save it as IMG or TIFF. If you don't save it, if you don't put it in an extension, it'll save it in an ArcGIS grid. Risk, output, that's 2.img.
Can you show me the that person? I've got something now.
Okay. So, Kristen, that works for me. Oh, no, it didn't. Never mind. So is this the same error you got? Total risk is not defined?
I defined total risk. The error that I got is none type object is not emergable. It says lines that obtain in module for data set in data sets. Line 17 is right there. What data sets in data sets? But I'm
So
I think I defined total risk after I sent it to you.
okay. So how about it's because mine ran. So I think that the difference is probably that your inputs don't look the same as mine. So like, did you type in risk down here at all? I wonder if I leave this blank, if I get that error that you got, just because that would be a good test, because we wanted to be able to leave it blank. Did yours go almost instantly to that?
Well, we're running off of our flash drive right now, so it just runs a little slower than yours in general, but.
Yeah, but Kristen's none type. Kristen's none type error. Okay. All right. Well, did you say that yours ran, Bryce?
Mine ran, gave me an image.
Great.
That I hope is right.
Yeah, it's going to be right. Yours is still saying that none type error. I'm trying to replicate that. I mean, I'm running your exact script. I didn't modify your script at all, Kristen. And
like if you open up the window in Python, does it run?
no, it won't run in Python anymore, because now you're feeding it that's one of the differences between running it as a toolbox and running it regular. That if you run it in toolbox,
It has the parameters.
it has those parameters, and so if you try to run that same script in the Python window, you're feeding it a bunch of empty data.
Okay, yeah, it works. I was trying to run it in Python.
Okay.
That would be.
Yeah. Interesting. Okay, so temp. So here's the two ones that what did I call them? Test. Refresh.
Yeah, I did have it in there earlier. For some reason, it's like not reconciling this actual script. For some reason, it's not Python.
Oh look, I ran it once from here too. This is the error you got. Non-type object is not iterable?
Yeah.
Yep. Okay. All right, where did I save it? Do you know where I saved these when I was running them? I saved them C data for some reason. Okay. So here is what it should look like. C. What is yours? Does yours look something like this on the coast?
More or less.
Yeah. Or does it look like this? I ran it twice. This is the way it looks the second time.
It looks more like the first one.
Okay. So the difference between the two times I ran it is I used just the risk layers for this one, and I used all the layers. I changed the filter. I just selected nothing, and I got that. The point of the tool was, oh, go ahead, sir.
Okay, I can't reconcile my script with a toolbox for some reason. When I run it, all I get.
So we'll go ahead and take like a 15 or 20-minute break. I'm gonna help Caleb a little bit. I'll take like a 15-minute break, and then we'll get done with stuff.
This is gonna be.
It's gonna be the targets.
Let's go.
You don't have to.
All right. For some reason, it's not signing my script. Oh, it's not showing something.
How did you do this?
Yeah.
This is actually this.
Oh, Cloud 10. That's.
What are you doing? So what did you do? Something different?
I don't know what else to do.
I didn't know.
What was really?
I meant like what was the value for?
I had a name for it, and then my script just made something else. That's why I couldn't find it. It's because I had two separate things that I was trying to reconcile the same thing. That's why. Yeah. All right, now.
Now you're gonna get some other.
I'm
I'm not very optimistic on that. That's just what happens to me. Never mind. It looks like it's well now.
Probably about 15 minutes when you come back, it'll,
That's right in here. I'm gonna save what we've got so far up here. Error? Oh, I thought you were saying, oh dang, about an error.
She's reading my mind up here about kind of scary.
All right, so yeah, now we're officially taking our break at 6:04, so come back at about 6:20. I'm gonna unplug this so that I can do something.